going to show you how to use the LibreText calculator to conduct a hypothesis test about the mean. And in this problem, it states, it takes an average of 12.9 minutes for blood to begin clotting after an injury. An EMT wants to see if the average will change if this patient is immediately told the truth about the injury. I'm not sure why that would be. The EMT randomly selected 62 injured patients to immediately tell the truth about the injury and noticed they averaged 13.6 minutes clotting time with standard deviation 2.29. So what can we conclude at alpha equals 0.05 significance? So let's write down the information we're given. The purported average for clotting time is mu naught equal 12.9 minutes. We collect a sample of 62 people, n is 62, and they have an average clotting time of 13.6 minutes with a sample standard deviation, S, of 2.29. Now, we want to test a claim about a mean, so we want to use a t-test for the population mean. We're not told the population standard deviation, but n is greater than 62, so we can use the t-test. Let's state the null and alternative hypotheses. The null hypothesis always has equality in it. So in this case, the null hypothesis is that the mean is 12.9. And the alternative hypothesis, HA, is that the mean is different from 12.9, so not equal to 12.9. Now, when the alternative hypothesis is a not equal, that's a two-tailed test. So now we're going to jump over to this list of calculators to record the test statistic and the p-value. So you're going to come down and click on hypothesis test for mean with statistics. Sigma is unknown, so make sure that that is clicked, and then enter what we have. S is 2.29, X bar is 13.6, N is 62, and the claimed mean is 12.9. This is a two-tailed test, so click not equal to, and then click calculate, and there we get the test statistic and the p-value. So the test statistic to 3 decimals, by the way, there's a formula for the test statistic here, but we don't need that because we're having a calculator do this for us. The test statistic is 2.407, and the p-value to 4 decimals is 0.0191. So if this is our t-distribution here, then our test statistic is about here, 2.407. And the p-value, since this is a two-tailed test, is twice the area in this tail. So what should we do? The rule is, if p is low, the null must go. So in this case, the probability that if H0 were true and we selected another 62 people, we would get a test statistic as extreme as the one we got. That probability is pretty low. It's 0.0191. So in this case, 0.0191, the p-value is less than or equal to our significance level, which is 0.05. Thus, since p is low, the null must go, we reject H0. And to state that in a conclusion, we say the data suggests the population mean is significantly different from 12.9 at alpha equal, I believe this was 0.05. So there is statistically significant evidence to conclude that the population mean for blood to begin clotting after an injury, if the patient is told the truth, is different from 12.9. I hope this helps.